Hello students, welcome to Solves classes. Today we'll be solving the ISI Msqe question paper of year 2017. Today we'll be solving question number 1 and question number 2 from the paper. So let's begin with question number 1. In question number 1, it is said that we need to find out the dimension of the space which is spanned by the vectors -1 0 1, 2, -2 -1 0, 1, -3 2 0, 1, and 0 0 -1 and 1. So the four vectors that have been given are mentioned over here, and we need to find out the dimension of the space which is spanned by these vectors. The options are 1, 2, 3 and 4. So these are the four. Let us write down these four vectors. The four vectors are -1 0 1, 2, -2 -1 0, 1, -3 2 0, 1, and the fourth vector is 0 0 -1 and 1. What we'll do is first we'll check out the linear dependence and independence. Check the linear independence or linear dependence of these three vectors. So if these three vectors are linearly dependent, then the combination of the first two vectors will lead to the third vector. This is the condition for linearly dependent. So this is the condition that we are writing down now. So upon solving this, we'll get the equations. A into -1 is minus of A, minus of 2B is equal to minus of 3. The second will be minus of B is equal to 2, and then A is equal to 0, and then 2 of A minus 2 of B is equal to 1. This is the third part. So as you can see, if this implies that B is equal to minus of 2. So if we put the values of A and B over here, then minus A minus 2B gives minus of A is 0 and minus of 2B is minus 2 into minus 2, that is equal to 4. So this is not equal to minus 3. This is not satisfied. Also, if we put A equal to 0 and B equal to minus 3 over here, then this gives us minus of 2 into minus of 2. This gives us 4, which is not equal to 1. So as you can see that the values of A and B that we have found out do not satisfy the other two equations. So as such, we can say that no A and B exist. Therefore the vectors are linearly independent. This is what we've got, and now we'll proceed towards solving the question. So in this case, we can now write, for finding out the vector space, we'll take the combination of the first three vectors -1 0 1 2 into B into -2 -1 0 1. The third vector is C into -3 2 0 1, and that will be equal to the fourth vector, which is equal 0 0 -1 and 1. Remember, the ABC that we are taking over here is not the same as the previous ABC. Now it is a completely different scenario. So now when we write it in an equation format, let me go to the next page. Let me insert a new page over here. So now the equations that we'll get are minus of A, minus of 2B, minus of 3C, that is equal to 0. The second equation is minus of B plus 2C is equal to 0. The third equation is A is equal to minus of 1, and the third equation is twice A plus B plus C is equal to 1. So what we'll do over here is that we'll try to solve these three equations at first, and the values of a, b, c that we'll get from here, we'll try to put these values of ABC into this equation, and if this equation is satisfied by the values of ABC, then in that case we can use the concept of dimension to find out the value of dimension. So what we'll do, we have been already given that a is equal to -1, so this implies that this equation will become 1 minus 2b minus 3c is equal to 0. This implies that 2b plus 3c is equal to 1. This is the first equation. And also we know that minus of b plus twice of c is equal to 0. This will be equation 2. Now if we add equation 1 to twice of equation 2, that gives us that 2b plus 3c equal to 1, and minus of 2b plus 4c is equal to 0. Upon addition, this gives us 7 of c is equal to 1. This implies that c is equal to 1 by 7. That implies that b is equal to twice of c. Now b is equal to 2 by 7. So we have found out that a, b and c is equal to minus of 1, 2 by 7 and 1 by 7. Now if we try to put these values in the fourth equation that we are here, so that will give us 2a plus b plus c will be equal to 2 into minus 1 plus 2 by 7 plus 1 by 7, that will be equal to minus of 2 plus 3 by 7, that will be equal to minus 14 plus 3 is equal to minus 11 by 7, which is not equal to 1. Is not equal to 1. So the fourth equation is not satisfied. In that case, we can only say that a dimension of the vector space will be equal to 4, which is the option D. Now we'll move on to the next question. The next question is question number 2. In question number 2, it has been said that we need to find out how many onto functions are there from a set A with m greater than 2 elements. So the set A has m elements and m is greater than 2, to a set B with 2 elements. We need to find out the number of onto functions that can be found in this scenario. The options that are given are 2 to the power m, 2 to the power m minus 1, 2 to the power m minus 1 minus of 2, 2 to the power m minus 2. So these are the 4 options that we need to check out. So we can write, let f be the function that we are discussing over here. If f is the function, then f goes from the set A to a set which has 2 elements. So we can write that set as the element, or a set having 2 elements, we can write it as 1, 2. Say this is the scenario that we are talking for. And also it has been said that the set A has m elements, where m is greater than 2. This is the condition. So in that case, we can say that a number of functions if A has m elements is given by 2 to the power m. The first element can choose any one of the 2 values, so there are 2 options. Similarly, the next option can take 2 values, so that 2 will multiply m times, and that gives us 2 to the power m. Now if number of functions, if there is only one element in m, if there is only one element, if number of functions, if there is only one element in set A. For example, if this if the set is of the form integer having the value 1 or the value 2, in that case the number of functions will be 2. So the number of onto functions required in our case will be equal to 2 to the power m, and we'll subtract these two functions, 2 to the power m minus of 2, which is nothing but the option D. So today we have solved question number 1 and question number 2 from the ISI Msqe question paper of year 2017. We'll be solving the next questions in the subsequent videos. Till then, keep watching Sources Classes videos for more solutions and content. Thank you very much.